our two-way analysis of variance lectures, identifying effects and interpreting those effects. So just lots of question examples. I think there are about 15 of them. So I'm just going to go through these. The quiz is done. Just want to talk a little bit about this. So this first one here, look at these means and see if you can guess, like actually pause this and see if you can guess whether there's going to be a main effect of factor B, a main effect of sex, or a main effect of the interaction. Okay, now I'll give my opinion on this. The main effect of factor B would be, is the mean of these two things combined, so the mean would be about in there, and the mean of these two things combined, the mean would be pretty close, a little higher, and the mean of these two things combined, is there variability among those means? It looks like there is. There's going to be a mean up here, a mean between these 2 points here, and a mean between these 2 points here. So I think B would be significant. The effect of sex, is the average of the black dots higher than the average of the red dots? Absolutely. So I think there's probably an effect of sex. Now, B by sex, yeah. First off, the lines are not parallel. But you can also think of it as the effect of sex at this SV level here is that females are way down here, males are up here. It's pretty similar to LV, but then when you get to NOR, whatever the hell that is, now the females are much closer to the males. So far, far, close. Yeah, that depends. The pattern changes as you go across the levels of the other variable. So here's another one. See if you can answer these questions. Are they going to be statistically significant as we go along? Okay, now I'll talk about it. Factor A is black line versus red line. Is the mean of the red line, the red dots, different from the mean of the black dots? Yeah, the mean of the red dots is probably about here. The mean of the black dots is about here. It looks kind of a big difference. So yes, factor B. So is the mean here different from the mean here, different from the mean here? Yeah, the mean here is about halfway between those two things, so about like there. And it's a lot higher here, and it's somewhat higher here. So I would suspect that there is a difference. The mean difference between those two things is at each point, those three means are going to be different from each other. Now, interaction effect, no. I would say it's not statistically significant. These lines are parallel, no effect of interaction. So you can say, what's the effect of factor A at the different levels of factor B? Does it depend on the level of factor B? No, it doesn't. It's always A0 is down here and A1 is up here. A0 is down here, A1 is up here. A0 is down here, A1 is up here, and by about the same amount each time. So parallel lines, no significant difference. So interaction plot for another A and B. See if you can answer this yourself. Now I will chime in. So factor A, the question is the mean of the black dots different from the mean of the red dots? I think so. The mean of the black dots is going to be here somewhere, about this high, about 10.7 or something. And the mean of the red dots looks like it's going to be up around like 11.6 maybe. Yeah, that's a pretty big difference. I mean, within the confines of this graph, not knowing anything about the variability, it looks like there's probably a difference. Now, factor B, is this different from this, different from this? I think so. This is going to be about the same as this, pretty close, because the difference here is halfway between this red and black dot, and halfway between this red and black dot. There's a little bit of difference that might not be significant, but then there's a big difference of both of those two from this one down here. So I think maybe A and B are significant. Interaction effect, well, just flat out, the lines right off the top, right off the bat, the lines are not parallel. So yes, an interaction effect. So the pattern as we go up here of A0 versus A1, low here, high here, by about a 1 point difference. Again, about a 1 point difference. And then here, almost the same. So this pattern here, and now a different pattern. So the pattern changes. The pattern of differences between red and black dots changes as you go across 1, 2, and 3, the levels of factor B. So yes, significant difference. Now here, okay, I'll I'll chime in here. The effective automobile model. I don't know. So this mean here is maybe like there. This mean here might be a little higher because that point's up there. I might say no. There's no effective automobile model. The mean of automobile model is the mean of all the different gasoline types among all the different gasoline types for Model A. It's probably about the same as Model B. There'll be small differences, but not big ones. So I might guess that there's no significant effect for automobile model. Gas type, yes. The black dots are very high. Green dots come next. The average of the red dots and the blue dots. Those lines are very separate from each other. Now the interaction effect, it's going to be a judgment call. You'd have to look at the numbers to find out, but it looks like maybe if you had a significant sample size there, a good sized sample. So these lines are not parallel, especially that little pokey thing there is not parallel to these other lines. So green and blue are pretty parallel, but red is not parallel to them and black is not, and in different ways. So maybe we would find a significant interaction effect there. Now here, it's another judgment call on the interaction term. So temperature, that mean is up here. The temperature, low temperature, the mean of thickness is about there. Medium, mid temperature, the mean is about there. And high temperature, the mean is about there. So these two might not be different, but that one's definitely different from the other two. Now pressure, low, about there, mid, about there, and high about there. Not a big difference in the means, but maybe enough to say that, yeah, there is variability among those means. Interaction term, it's all kind of depending on what's happening here with this little x. It looks like there is an interaction, but it'll depend on how much variability there is within the groups and how big a sample size they have to determine whether that's statistically significant or not. I'm going to skip past a few of these and let you work on them and think about them. If you have questions, you can ask me, and I'll talk about a few that look kind of interesting. Here's one. The mean of education level. School, college, university. Yes, the mean of school is down here, college is here, and university is very high. So the politics level is very different based on which schooling level you had. However, the effect of male versus female isn't very big, and it kind of reverses a little bit there. So the means, the green line is not much different from the blue line. So the mean of the blue might be here, and the mean of the green might be here. They're going to be pretty close to each other. It might not be statistically significantly different, so there might not be an effect of gender. And the interaction, those aren't parallel, but they're not very non-parallel. They're close to parallel, so depending on the sample size. If there's a large sample size and really tight variability within each group, then yeah, that'll be significant. But if there's a smaller sample size or a lot of variability within groups, then that will not be statistically significant. That one I'll leave you to puzzle out. Looks like fun. This one was entertaining to find. This is one where you might have an effect of both A and B, but perhaps not of the interaction, because the lines are close to parallel. So it would depend on the sample size and the variability within each group. Now notice this kind of dot doesn't give you the points at the end. It just shows you the lines, and you have to imagine where the lines end, that those are the means. And so ways people do it sometimes. Now here's a clear example of both A and B, x1 and x2, have significant effects, because the mean of x2 level 1 is up here, and x2 level 0 is down here. So those are very different for x2. And x1, the mean of the zeros is here, and the mean of x2 0 is here. So very different. So this is about 0.5, and this is about 1.5. So very different. So both main effects are significant, but the interaction effect is not significant because those lines are dead parallel. The pattern is the same across the levels of the other variable. Well, this is an interesting one. The effect of x1, here's the mean of x1 at 0. It's about 0.5. Interestingly, the mean of x1 at level 1 is also 0.5, very symmetrical. This is a computer-generated example. This wouldn't be this perfect in real life. There is no effect of x1. Does that make sense? Because the mean of x1 at this level is the same as the mean of x1 at this level. So these two groups here, when you average them together, they have this mean. These two groups here, when you average them, they have this mean. Now, the effect of x2, what's the mean of those two things? So you have to average this plus this, and you get a mean that's right in the middle again. And the other level, you'll average this, and you get something that's dead on top of it. So there is no significant effect for factor A or for factor B, but there is most definitely an interaction effect. And that can be one of the most interesting things to find in science, that the individual factors are not statistically significant. And so you never would have found anything interesting unless you had done this two-way procedure. But then you find that the interaction term is significant. And one of the classic ways this happens is with this X pattern, where the mean effects just reverse themselves across from levels of one factor to the next level of that factor. So that's an interesting one. I'm not going to talk much about this one. Here we have the effects. Probably both A and B are statistically significant, but not the interaction. Unless you had a huge sample size, so that tiny non-paralleleness would become statistically significant. Here we have real data showing the classic X effect, so that there might not be any effect of online purpose or any effect of the affect while online, but you would have an interaction effect. Now, interpreting these things, you just have to go cell by cell until you figure out what's going on. So here, what was your online purpose? Browsing. When your online purpose was browsing, then your negative affect, when you were browsing and you were unhappy, then you spent very little time online. But it was browsing, but when it was buying and you were unhappy, you spent a lot of time online. Oh, that makes sense. Maybe it's comfort buying. Now, if you were happy and browsing, you spent a lot of time online. But if you were happy and buying, you spent little time online. So the effect of your mood is opposite as far as how much time it makes you spend online, depending on what you're doing, whether you're buying or browsing. You just have to work through step by step, look at each of the means, and try and form some conceptualization in your head of what's going on there. Here we probably have an effect of one variable but not the other. So putty versus powder, there's very little difference there. The red line and the blue line are very close together, so maybe there's no effect of fill substance, unless there's a very large sample size or very, very tiny variability in there. But the effect of time is big.